in general, when you solve a system of equations, it's a solution that makes them both true. I said both, but we could have more than 2 equations, so it makes all of the equations true. If it has a solution, then the term we use for that is called consistent. In terms of lines, if you have 2 lines and they have a solution, what that means is the lines meet somewhere. So that point is the solution. That would be a scenario where it's consistent and what we call independent. They're 2 separate lines. If you have a solution, but you get infinite solutions. Infinite solutions is when we say it's consistent and dependent. Infinite solutions happens if I give you 2 equations for the same line. So you really just have 1 line there. Every point on the line makes both of the equations true. Dependent, they depend on one another since they are the same line. And the term we're going to use the most, if it does not have a solution, we call it inconsistent. In terms of lines, what would be the only case you could have 2 lines that don't meet? Parallel. Well, those do not look parallel, but let's pretend I can draw on that they are. Okay? So those are never going to meet. We're done that. So let's solve one by substitution again. So to start out with substitution, what do you have to do? Take one of the equations, solve for one of the variables. Which one do you want to do? Okay, solve the bottom equation for x. So you would just add your y. So x is 4 plus y. Then you substitute that into the other equation. So I go to the second one, or the first equation here. Instead of my x, I will put 4 plus y. And then we just solve. So I get y equals 2. Then what do we do with that? Plug it in to solve for x. You could really put it in anywhere, but the easiest place is going to be right here. I know x is 4 plus y, so 4 plus 2 is 6. I want you to write these as an ordered pair. So ordered pair x comma y, so 6 comma 2. These are easy to check. It has to make both equations true. So 6 plus 2 equals 8, 6 minus 2 equals 4. It works. You ready for yours? So solve by substitution. What's the easiest thing to solve for? Y in the first equation, just because that's coefficient of 1. Doesn't mean you can't solve for any of the others. So y is 5 minus 2x. You always have to plug that into the equation you have not used. So I'll plug it into the second one. So 16x plus 30 equals -2. Subtract over your 30. Divide by -16, and x is 2. We know y is 5 minus 2x. So plug that in and you get y to be 1. So how do I need the answer? Order pair 2, 1. Alright, do I need any more substitution examples? Second one, elimination. Bless you. Okay, so the goal in elimination is to be able to add your equations together and eliminate a variable. We want one of the variables to disappear. To do that, a lot of times you have to multiply one of the equations by something, or sometimes you might have to multiply them both. Pick a variable. What do you want to cancel out? X. Okay, so in order to cancel, they have to have the same but opposite coefficients. So we need to turn them both into a either 2 or 4. We could do it either way. If you wanted to, more of you said 4, so we would take this one times 2. Okay. So now, in my top equation, if you take everything times 2, you get 4x plus 2y equals 10. Bottom one, we did not have to change. Alright, so when I add those, the x's drop. So I have 8y equals 22. Divide by 8, I'm not going to get a nice pretty answer, but that's okay. I don't want you to round decimals. So if it came out to be like 0.3 repeating, don't tell me 0.3, give me 1/3. If it comes out nicely, I don't care if you do fractions or decimals. So this one would be 11 over 4, or 2.75. So either way is fine here. Now I have to find my x. So you need to go back and plug that into one of the two original equations. Which one do you prefer? Okay. So if I subtract that 11/4 over, divide by 2, I get 9 over 8, or 1.125. So final answer, ordered pair, x comma y. I can give you guys one to do. What did you multiply by? -2 on the top. So -4x minus 2y equals -10. Positive 4x plus 2y equals 8. Add those together, x and y cancel, so we have 0 equals -2. What does that mean? No solution, and what do I want you to write with that? Alright. That one okay? Let's do one with some fractions. So if I wanted to solve this by elimination, what would I need to multiply by?
-1/2.
Okay, you could take,
On the top.
well, that would turn it into a -1/6, but we want a 6. So you could, -2 would turn that into a -2/3. Okay, so do we need to do this in more than one step? What about if I just said, let's get rid of a fraction? What would I multiply the top one by to get rid of all my fractions? 6. Can we agree with that? Let's start there. If I just multiply that one by 6, 6 times a third gives me 2x. 6 times 1/6 is 1y. 6 times 2/3 is 4. So if you have to, get rid of your fraction first. Now what do you want to multiply by? 3 on the bottom. Okay, so my equations. what happens? Everything cancels. I have 0 equals 0. That's not no solution. That's infinite solutions. Now, in algebra 2, you got away with just writing infinite solutions, but we're not going to anymore. We are going to describe the solutions because it's not saying every possible number order pair I pick works. It's only the order pairs that are on this line to begin with. So, on the homework or test or quiz, I will say if there are infinite solutions, write your solution with, and then I'm going to pick a variable. I'm going to say y arbitrary. Okay, what that means is I want you to try to describe to me what these order pairs look like. If I say write it with y arbitrary, y is the variable we are going to use. So in an order pair, we know it is x comma y. I'm saying leave y by itself. I want you to come up with an expression that would help me find my x using y as the variable. So all we have to do is take one of our equations, let's pick this one, and let's solve for x. So if I want to get x by itself, I would add my 3y over, and then what would I do? Divide everything by -6. So x is -2 minus 1/2 y. Oh, yes, thank you. Missed my negative. 2 minus 1/2 y. There are different ways of writing this. You might have, if you had one big fraction, 4 minus y all over 2 would be fine. 2 minus y over 2 would be fine. But because I said y arbitrary, y is the variable I keep. If I said x arbitrary, you would have x comma and then something for y where the variable was x. So this says if I pick any y value, you can tell me what the x would have to be so that it would fall on this line. Questions there? Do I need to do another one where you have to write the solution with y arbitrary? A few of you shook your heads yes. So why don't you guys try this one for me? You guys get 0 equals 0, so we know there are infinite solutions. To describe them, I want y arbitrary, so you take one of the equations, I'll just go with the first one, and solve for your y. So x is 4 minus 2y. So your solution is 4 minus 2y comma y. Yes?
Will we get counted off if we put -2y?
Oh, absolutely. So -2y plus 4 would be fine. All right, are there any questions about this stuff? Okay, so here's the twist. The section 5.1 is all the linear stuff. Section 5.5 is nonlinear systems. Our strategies are going to be the same though, substitution and elimination. So we're going to do maybe 3 of these and then I'm going to be done. If I'm looking at this problem, I have, in a sense, really 3 variables. I have an x squared, I have an x, and I have a y. Which one do you think I would like to get rid of? The x squared would be an option. Or if we got rid of the y, we would have everything in terms of one letter, an x squared and an x. So a lot of these, there are different routes you could take. If you just look at this problem, do you see anything nice about it? Okay, if I could eliminate y without doing any work. So if I just add those, my y's drop. Can I actually add x squared and x? So I'm just going to leave that as x squared plus x equals 2. Now what would you do? This is a quadratic, set it equal to 0. We can do box method. Multiply to -2, add to +1. Set each of those to 0 and we get x to be a -2 and a +1. We have to find the y to go with each of those. Which equation do you want to plug it into to find y? Second one. So -2 plus y equals -2. If I add my -2 over, I get y equals 0. So that is one ordered pair. When my x is -2, my y is 0. Now I have to plug in my 1. So again, just go back and plug it into that second equation, and I would get, my board is not working, x plus y, so 1 plus y equals -2. Subtract your 1, we get -3. So this one will be 1, -3. What happens is, if they're linear, you're only getting one solution. If they're nonlinear, you might get more than one. We might get 2, 4, we don't know. So we have to actually pay close attention and work it out. Questions on that? So same strategies, just more answers.
Is elimination
Most likely. Yeah, you could have, this one wouldn't be too bad to do substitution for if you'd like solve for y in the second one and plugged it in. But usually I stick with elimination for these. This one. And I haven't been doing it, but you guys realize you can check all of these by plugging them back in, right? I think I did on the first one, but I haven't since. Okay, this one we have x squared and we have a y squared. What do you want to do? All right. Yeah, we don't really even have to do anything there. Once again, I can just add these, and those drop out. So I have 3x squared equals 12. Divide our 3. Oops. To get rid of a square root, what else do I have to put with that? So I get x equals plus and minus 2. Let's find our solutions. If x is positive 2, plug that in. Let's go to the first one. If I put that in for my x, 2 squared is 4. Subtract that. Square root of 0 is just 0. So I get 2, 0. What's going to happen when I put in -2? Same thing, because a -2 squared is positive 4 as well. So my answers are 2, 0, and -2, 0. I do want you to write them separately. I don't want you to put plus and minus 2, 0. Write or separate word here. Okay. So far, so good. Let's do one last problem. Top 1 times -3. add those, the y squareds drop. Negative 3x squared and positive 4x squared is 1x squared. Negative 15 and positive 11 is negative 4. When you square root this one, what kind of answer are we getting? Imaginary, and that's okay. I do want you to still give me the imaginary. So I get plus and minus, the square root of negative 4 is 2i. Okay, we have to plug this thing back in. So, if x is a positive 2i, two I squared is negative 4, because it'd be 4 times I squared, and I squared is negative 1. Subtract your 4, or sorry, add your 4, so you get y squared equals 9. Square root, and you get plus and minus 3. So when my x is 2i, how many different ordered pairs do I have? 2 of them. I have 2i positive 3, and I have 2i negative 3. What happens if my x is a negative 2i? Same thing, isn't it? Because 2i, negative 2i squared is still negative 4. So I have 2 more answers. Negative 2i, 3, and negative 2i, 8.
If we would have started with eliminating x, would we get a different answer?
No, you should get the same answer. You may look at them. So then we go to the plus and minus 3.
Can I ask you this one?
Okay, so we've got a little bit of time left. My goal is for you to not have homework over Thanksgiving, so there is a handout posted on Classroom. It's 8 questions, and I think you have time to get very close to done, if not